Yeah, thank you everybody for joining today. Let's take a look at for today, we're going to be discussing, the agenda today is we're going to talk about some of the cloud native observability challenges, things related to data and also organizational complexity and what it means to the organization when adopting cloud native. And then we're going to talk about what we call the new world observability requirements. What is required to be successful and to allow for a platform to be performant and also cost effective? What are the requirements there? And then we will jump into a demo. John is going to actually walk us through a demo and show you how the Chronosphere control plane actually works. And that'll be very interesting to see some of the things around analyzing and shaping the data. And he'll show you some of the delegation capabilities and also some of the ways that we help optimize. And then we will do a quick recap and Q&A and go from there. So first, we're going to start with a poll question. Just want to get a sense of where everybody is on their cloud native journey. So as you can see here, you might be just getting started. That's great. You might just be thinking about it, and that's also great. So wherever you are, just let us know, just so we can get an idea, so we can maybe tailor this a little bit to the conversation. I know John's worked with lots of different clients across all different spectrums, so he'll be able to do a good job of making sure we get the information that you need based on where you are.
Yeah, I've worked on monoliths. I've worked on service-oriented architectures, kind of run the gamut. And it's interesting how the kind of problems that we'll be discussing today start to creep in as the architecture evolves too. It's pretty gradual in my experience, but then it kind of comes on really quickly when you start getting into full microservices running in the cloud.
Okay, all right, we have the results here. Let's see. Got a few monolith running on-prem, and then it looks like the majority is in the middle there, making the move and starting the plan, and also a mix of microservices and monolith, and another just at a full microservices. Cool. All right. That's great information. Thank you for taking time to vote on that. So as I said, we're going to talk through some of the challenges. One of the first challenges that you'll face is the growth of observability data. And what happens is, and this is kind of something that's changed, as over time, observability costs have always been kind of one of those things that tracked kind of with the business growth. It's always been, something that people have looked at as an organization. I've worked at a few of these vendors, so I know that that's something that is, costs are always trying to be controlled. But when we hit the world of microservices and containers, it really started to decouple, and you can kind of see that here. Now it's really starting to outpace what is, it's growing faster than the business is actually. John, do you have anything you want to add to that?
I think maybe it's interesting to talk about this. I know we'll get into it in a little more detail in the next couple of slides, but the reason why this happens, right? If we think about the evolution of architecture that's happening here, we go from more monolithic applications running on-prem in the data center to full-blown containerized microservices in the cloud. What we're really doing is we're taking these application architectures and making them a lot more components that are a lot smaller individually running, so that we get more flexibility in how we can operate our system, take advantage of the flexibility of the cloud. But the consequence of that is there's a lot more things for us to have to monitor and watch, and therefore a lot more data.
Yeah. So actually, let's move to the next slide, and we can kind of discuss and this is to set this up basically. If you take the same application that's running on a VM and you break that into microservices, and then you add some experiments, and there's more pods running there, you've essentially almost 100x to that data, right? Just by making the move to microservices.
Yep. This is a pretty simple example that we're illustrating here, but it really does help to illustrate the kind of order of magnitude increases in data that we see when you do this kind of architectural shift. And again, it results from, we've got a lot more moving parts that we have to account for and monitor, and a lot more complex relationships that we're trying to understand and keep track of within the same architecture. It's the same overall footprint in terms of, what are we able to serve, or close enough at the very least. But there's a lot more pieces within it that we need to be able to understand, a lot more relationships between those pieces that we want to be able to keep track of. And that causes, 10x, 100x, even 1,000x increase in the amount of data that we end up seeing getting ingested into our observability platforms.
And the idea that service teams now, right, they were kind of coupled to that monolith. And so the experimentation that they could do and the tracking that they could do is pretty limited, and they weren't able to make quick changes. So now experiments play a big part in that, right?
Yeah, absolutely. One of the reasons why we kind of moved into this direction and moved into these architectures, besides taking advantage of the flexibility of cloud environments, is also decoupling application dependencies, making it easier to run these quick turn experiments and iterate more quickly on product functionality and features, rather than having to bake a big release and ship it once a quarter or something like that. You want to be able to do several different releases or experiments a day, and that also has a big impact for sure.
And so if we look at what's the impact of this, right? So obviously cost is going to be a problem, because if you're ingesting more data and you're storing more data, and then you're going to have to pay for more data. But I think there's also a flip side to this, right? That people may not really consider at first, especially if they haven't experienced it, around the performance issues that might happen when they start to query these large sets of data, or other aspects of loading dashboards and things like that. So why don't you talk a little bit about that?
Yeah, performance is definitely a big concern here. And it really makes sense when you think about it. If you increase the amount of data that we're dealing with by an order of magnitude, that means that when you go and fetch that data to load and render a dashboard, you're probably querying back an order of magnitude more data. And it's really a bit of a physics problem when you get to really large scales of, if I'm trying to fetch several gigabytes of information to load a dashboard, that's a lot of information for me to have to, pull back from storage and then do some sort of computation on, and then return the results to the user and render it in a set of charts. And it really does kind of go in line with the volume of data that customers are trying to manage in a lot of cases. We see this a lot with our customers at Chronosphere, where they've had spiraling data growth problems that they're struggling with when they come to us, and that sometimes observability performance is kind of a secondary concern for them. But when they get their data growth under control, they see fantastically improved performance across the board. It ends up being actually almost a bigger value point for the engineering teams than the cost management.
Yeah. And so obviously those are two big problems. I think there's also this issue that isn't really talked about a lot, which is the complexity of the organization, right? As you move to cloud native, the structure of your systems change, but also the structure of your organization is going to change, right? So if we look at this, next slide here, in the old world, right, as we call it, the monolithic world, things were simpler, right? And to a degree, I guess, but.
So yeah, definitely simpler in the sense that you had a lot fewer discrete components that were being deployed in your system. The monoliths that we talk about fondly from our days in on-prem were a lot more complex than individual microservices, of course. Generally, they've got several different subsystems. You think about the different colored blocks in the diagram here. But the number of things that you were kind of monitoring and reasoning about within your system was a lot smaller compared to what we tend to deal with these days.
Yeah. And so as we talked about, as you break these apart, you're now dividing these into smaller teams who are responsible for these services. It gives you that speed and agility, but it also gives you complexity, right? So talk a little bit, I mean, at this size, like if you've got a few services and you got a few people broken up to teams, it's pretty manageable, but that changes quickly, right?
Yeah, absolutely. If your architecture diagram looks like this, you probably don't have a problem. Going from one service to 3 equal storage backends, that's not a big deal at all. But we know that reality is often a lot more complex. And so as your organization starts experimenting with microservices, it looks great at first. The individual service owner teams can iterate quickly. They don't have to be chained to the monolith anymore. It has a lot of benefits. There's a reason why we do this, right? But as that complexity starts to grow and you have more services and more dependencies, yeah, that probably starts looking more familiar to people.
Yeah. And some may know this is Conway's law, right? It's your systems or reflect the organization. Your organization reflects the way you develop software, deliver software. So that's what happens here, right? It gets to a tipping point where you may have known the 5 teams that were running those services and you could quickly reach out to them when a problem happens, but now you're running, I don't know, what do some of our customers have? Tens, thousands, hundreds of teams? I mean,
Yeah, hundreds, if not thousands, of microservices. Some teams own a couple of them. Some teams it's a 1-to-1 ratio. It does kind of boggle the mind sometimes.
yeah.
And it's interesting to me because when you think about the evolution here, the benefits are obviously you have all these things that you can iterate on independently and have very rapid development cycles and be able to manage the unique needs of each individual aspect of the system as a whole within your cloud environment. But from a holistic perspective, the relationships between your services almost become more of a what's the phrase I'm looking for? It's more important to understanding your behavior and reliability than the individual services themselves, because the individual services themselves are so much more simple than what we were used to dealing with back in the day. But now they have so many different moving parts that form these kind of crazy dependency chains that a request actually goes through. One user request ends up touching 100 different services in the back end, and being able to reason about that and understand it and be able to guarantee the performance and availability of it. It's a very different conversation than what we have been having historically in the industry.
Yeah, and that's really what changes, right? So now you've got all these teams doing their independent thing. If you're doing this well, your team should be very small. They should be shipping small updates very frequently. And when you make all those changes, I like to say, like, everything that gets introduced, like especially around observability from as you're doing tagging or metrics, and it's all done by people, right? I guess any system change is done by people. So you have to be able to understand how to manage that complexity without putting the brakes on them. And so, something like as we move to a small change can have a really big impact, right? It's like this small change versus the reverse of the monolith, right? It was like a change can have it has an impact, but it's a much smaller impact. It's like this, it can grow very quickly. And so as one team makes a mistake or decides to add a UID tag or something to a system, it becomes a problem, right? Because now it's like, what do I do? Who did it? Where did this come from, right?
Yeah, I think we tend to think about this a lot more when it comes to things like dependency chains in user requests. Like I have a shared dependency that actually is powering a lot of my functionality that my users interact with, and if that service has a failure, then it's going to impact a big swath of functionality in my application. But when you think about it for observability data, there's kind of a similar problem where you've got all these different sources where failures can pop up, but because of the relationships that we've kind of built here, and because of the cardinality that starts to rise up because of tracking those relationships, the impact of one team making a not necessarily a mistake, but introducing more data than they anticipated, right? We tend to refer to these as cardinality explosions or cardinality spikes. Those spikes are so much bigger than they would have been if you were still running a monolith or a modest service-oriented architecture, because of the scale of the number of things that we're looking at, all the different components and relationships that we're tracking, the additional cardinality that we add into our systems, it's multiplicative. And so this is where it goes from, we've increased the amount of data for our baseline by something like an order of magnitude, and now somebody goes and does something that accidentally 10x's cardinality. That's a huge amount of data that you just generated by mistake. And because there's so many different moving parts that are being iterated on so quickly, going and finding where the problem got introduced and fixing it, that becomes a real kind of whodunit problem for teams.
Yeah, and so you're left with and this happens over and over again, right? So you're left with now the COT or the central observability team or the site reliability engineers are trying to figure out, where did it come from? Who did this? And they're doing this over and over and over again, right? They're basically spending a lot of their time just going around tamping out these cardinality spikes.
Yep. The stewards of your observability platform, they have a much higher stakes game that they're playing these days than before. If you have been managing metric stacks or things like that for a long time, you might remember back in the day something like this happening where graphite slows down because somebody accidentally introduced a bunch of new metrics, but it wasn't nearly as bad to identify and fix as it is these days. It's just such a larger increase in the scale of the problem that's being introduced with each incidental change. And the number of sources where it can come from have increased by, literal multiple orders of magnitude. It makes it an incredible challenge for teams to be able to try and manually hunt down offending causes of high cardinality and troublesome data generation, and then go and get it addressed. It's really a new consideration, I think, in terms of like what teams really need to be dealing with in their observability environments.
Yeah, and so, I mean, you're moving to cloud native for the speed, right? But all these things are happening and you're getting all these cardinality spikes and costs are spiking and system reliability is getting hit. So you could put speed bumps in, right? Like you could say, oh no, we got to check everything. But you're kind of losing the benefit, right? You went to cloud native for a reason. It wasn't just because it was the cool thing. It was because it gave you these benefits and it gave you these competitive advantages. But so you don't want to lose that, right? So it kind of comes down to, well, what do you do?
Yeah, this is kind of the double-edged sword of, the faster we're able to move, the more teams are able to do incremental changes and releases. That's good for the business as a whole, but it's more opportunities for incidental mistakes, cardinality explosions to get introduced that blow up your observability stack and cause hair on fire situations for the central observability team. And then you've got to go and try and figure it out because if our observability platform has a problem, then do we have operational insight into what's going on in production? We can't be running in a situation where we can't understand what's going on with our systems. And if there's massive explosions of cardinality all the time, then it's going to be a massive slowdown in your observability performance, even worse than what you deal with on a day-to-day basis, or just outright reliability issues where your observability platform falls over and now we have no visibility whatsoever.
And we've seen that, right? I mean, we've seen that happen to customers prior to Chronosphere.
Yeah, absolutely.
You set that straight. So that's why they came to us. So it kind of puts you in this, like, how do you fix this, right? It's kind of a catch-22. I know we have there's two outer bounds here, right? You can force limits. Nobody can go over X, or you're going to cut, or you can say, we don't have limits and we can't stop it. And so just keep collecting it and we'll figure out how to pay for it.
Yeah, on one hand, it's, we're going to put really strict boundaries on what happens. We want to make sure that the system is efficient and we want to make sure there's no cardinality explosions. And darn it, we're going to put the process in place to guarantee this. That usually means something like rigorous review on every single change that's being made, or, multiple levels of review on adding a new dimension to a metric, something like that. That ends up being really not fun for anyone involved. It massively slows down development velocity, and also starts ending up creating the scenario where developers are being forced to make choices about what data they capture for their applications. And usually they're not really well-informed choices. They're choices that are being made not necessarily arbitrarily, but by gut feel at best, and end up creating a situation where you don't have the visibility that you need to understand your system's behavior and make sure that it's behaving reliably in production. So you get higher incident rate, more time spent troubleshooting incidents, less time being spent doing releases, fewer releases overall, just really the opposite of what we were trying to do in the first place.
Yeah, and they're cutting, like you're like you said, you're kind of guessing. It's like, well, this metric doesn't look like it's really being used, but I'm not sure. So let's stop until somebody screams, right? Oh, I need that. And that's kind of the approach that it's kind of a whack-a-mole guess. And if somebody yells for it, we'll turn it back on. If not, then we're fine.
Or
and then I guess the other yeah. And then the other end of it is the no limit. So, but that also, we talked about earlier, like, right, the growing data, the cost issues, the slow dashboards, queries, those are things, performance issues. And it kind of gets us to the same place, right? I mean, we end up in the same, like, it's not neither one is a great fit. And then in the middle, as you were talking yesterday, the compromise, right? Compromise, it means everybody's unhappy, maybe. And that's not good for observability or for observability teams or developers.
Yeah, organizations in practice, right? You tend to try and balance between aggressively limiting data versus, oh, go crazy, it's all valuable and we're just going to deal with the fallout. You spread the pain around across kind of both paths and try and make it so that it hurts as little as possible, but you're still feeling this pain in a bunch of different places as a result. your observability tools as fast as you want. Finance or management grumbles that it's costing more than they'd really like. The team is still really not quite satisfied with the visibility that they're getting, but we're trying to not burn all the venture capital money that we've raised on fire in 1 month. We can get to the root cause of issues eventually, but it might require more escalations than we want, or it takes longer than we're hoping. You're kind of dancing on the knife's edge of your SLA commitments to your customers. Just really not a fun time for anyone in that situation. But it's the reality that a lot of teams that are running cloud native end up seeing themselves in, where they're really just trying to strike the best possible balance between two really tough situations, because that's all that is really available to them with the tooling that they have.
Yeah. And so you really need a solution that gives you that ability to let the developers, the development velocity, right? Let it go, push the stuff, push the code out there, make the fixes, make the updates, do the experiments, but you also need to maintain that visibility and control those costs. And that's really what Chronosphere is about, right? So our founders started the observability solution, built this for Uber, which was based on the M3 DB, and Uber open sourced that, and our founders were like, oh, they saw the problem firsthand. I think it was like the second largest production observability system. Is that right? I think it was the second largest.
Yeah.
And so, like the control thing, any one engineer could take down the observability system. And so, and that's what we're going to get into next, right? So do you have anything, you want to add anything to that?
I think just to emphasize it, really the problems that we're outlining are tooling problems. They're problems that have not been well considered by the observability industry because they weren't really issues in the past. There's something that have, really started to cause significant pain recently with the migration to cloud native. And maybe just to touch on the Uber story a little bit, the fundamental problem that our co-founders saw at Uber was that they kept running into situations where the volume of data that they were generating in metrics in particular was outpacing the growth of the business. Their monitoring costs were going up and up and up, and they kept trying to do these revolutionary changes to bring costs back down. And they tried to find tools in the industry that they could, kind of outsource the problem to, but there really wasn't anything at all. This was, a little ahead of the curve compared to everyone else at the time, but it was a problem that, just had not had any kind of consideration from the industry. These days, it's gotten better in terms of other companies' ability to cope and handle the scale and things like that. But the visibility and control problem that we just outlined is something that is still seriously unconsidered, I think, across the industry and across the space.
So let's move on to our second poll question here. And I want to continue this discussion though, right? So it's all the observability vendors are always talking about faster MTTR, faster time to resolution, or how easily their workflows are, but no one ever talks about controlling the data part of it, right? And because a lot of these tools weren't built they didn't have to consider that, right? It's like, this is kind of like a Blockbuster. Oh, Blockbuster, everybody, like Netflix comes along. Netflix all of a sudden now it's streaming. It's these things happen, and these companies, because of the way they're structured and the way they're built and they're publicly traded, it's hard for them to make that shift. So they just continue to try and bring in more data, and they use other things to try and make it better on the back end, like, different AI ops tooling. And then but you're paying for that data, and then open source world, it can start to impact the reliability as well, right?
Yeah, I think there's this long-standing assumption that we've held in the industry that more data is always more valuable, and that is true to an extent. But you have to be able to justify the cost of that additional data. And when you're staring down the barrel of 2 decades of exponential growth in cardinality for metrics, for example, it's really, really hard to be able to make the case that you can just kind of arbitrarily collect huge amounts of data, and paying for it is a no-brainer. And that's really the kind of situation that we find ourselves in today, where we are able to collect incredible amounts of information about our systems. And there's a lot of required information that we need in order to be able to understand their behavior and guarantee their reliability. But making sure that the data that we're collecting and storing and paying for matches the value that we're getting from it in practice is something that is actually a lot more challenging than it used to be. The value equation is not as simple as it was back in the good old days.
Yeah. All right, let's see. Okay. Few not a priority. Mindful. Yeah. All right. Again, pretty scales, almost similar to what the other poll was, but yeah, it's, trying to make improvements. And then a few people here are top priority. Okay, great.
It's surprising to me that most people are at least being mindful of cost right now. It's something we're hearing a lot talking to prospective customers, that cost has become a concern, if not an absolute priority for the business.
Yeah. All right, let's jump into, we're going to do a very quick overview just to make sure level set what Chronosphere is. And then we'll jump into a few demos here with John. So basically Chronosphere, we're a single tenant SaaS observability platform. As you probably figured out, there were observability platform, but our real differentiator here is that we are 100% open source. All the inputs that you put in, all the querying is done. Everything's open source. So if you aren't happy, you can take that data and go somewhere else. Basically, we don't hold you to a proprietary data format. As we talked about, the data store that we used is kind of based on the M3DB, which was created at Uber. So very, very highly scalable reliability. We have a SLA of 99.9, but we've typically hit 99.99. So, very, very reliable. And the piece we're really talking about today is this control plane. And what's unique, this is a very unique set of capabilities within Chronosphere. It allows you to do things like, we talk shaping, which is doing, making decisions about how you aggregate and things like that. It allows you to analyze your data and make smart decisions about how you want to store that data, what you keep, what you don't keep. And so that's what we're going to jump into right now, actually. So, John, we want to discuss quickly what you're going to demo, and then we'll jump right into it.
Yeah, I think there's a couple different use cases we're going to try and touch on here. So first, we'll talk about how you can mitigate the impact of cardinality explosions we've talked about here, and then dive into how you can better understand what your observability costs look like and where they're coming from, and then also make sure that you're getting the right ROI on the data that you're sending into Chronosphere. So these are tasks that are quite straightforward to do in the platform. I think it's going to take us about 15 minutes to get through all of this. Let's see how I do.
I will stop sharing and you can take over.
All right. And let me know when you can see.
Yep.
Awesome. Yeah, so starting off, kind of jumping right into how we can limit the blast radius for these cardinality explosions. There's functionality built into Chronosphere that allows us to basically set quotas on how much data can be admitted into the platform from a particular subset of our workload. So if you think about the slide that we showed before with all the different teams that own these different microservices, what we want to be able to do is ensure that when there is a cardinality explosion that happens, we're not impacting the entire business. We are limiting the impact of that to as small of a segment as possible, and also making it very easy to understand exactly where a problem is coming from, so that the service owners, rather than the central observability team, can actually go and respond to that issue and then go and address it. So the way we do this is by letting you set quotas on how much data is coming into the system, and then break that quota down by whatever subset of your workload you want it to be. In this case, I've got different pools allocated for different key services in my system. I've also got a large chunk of unused pool that's kind of sitting there on the side, and one for dev. And if you take a look at what these look like, here's an example of the pool for my orders service that's coming in here. It's allowed to send up to 2,000 data points per second into the platform. Right now, it's doing just a little over half that. So plenty of capacity for it. No issues in terms of what it's using versus what it's guaranteed. The way that this works is if there's a cardinality explosion and my order service starts sending, twice as much data or even more, we will track the data that's coming in compared to our total utilization. If there's capacity available in my total allowed limit, right now I've got plenty, then nothing happens. But if we hit that total allowed limit, 50,000 writes, then we'll start shedding data from these systems that are over their quota. So if that's the order service, then we'll start dropping data for the order service. Everyone else that has their own quota, their data is guaranteed to be let into the system. It's not going to get affected. It's not going to get touched. They'll never know that this happened unless they go and take a look and see that it did. And because these quotas are set up with tracking behind them to let you understand how you're doing, it's also very easy to configure alerts about this. For the central observability team, whoever is managing the system, they can configure alert that will let teams know when they're getting close to their quota, when they're exceeding it, when data is actually starting to get dropped, and have it get dispatched to the appropriate service owners for the given pool that they've got defined. And that way, rather than it being a situation where the central observability team has to go and figure out where spikes in data are coming from when you have a cardinality explosion, we actually know already because we're tracking it on a pool by pool basis. And the team that actually owns the quota can go and come into the system, jump in, understand what's going on with their data, and then take efforts to remediate it. They are effectively responsible for their own capacity. They can use it whichever way they see fit. And the team that actually owns the system as stewards don't have to worry about somebody making a mistake or someone being a bad actor in the system and negatively impacting the experience of everybody else. So once we've kind of got this set up, if you're getting a notification letting you know that like, hey, I'm at my quota, or I'm over my quota, or we're starting to see data get dropped because I'm over my quota, what we want to do is give teams the ability to understand what's happened that is causing that increase in data volume that I need to go and address. If I'm having a cardinality explosion, can you point me exactly to where it's coming from? And we actually do make this very easy to get to the bottom of quite quickly within Chronosphere. So the way that we do this is by letting teams understand the data that's coming into the platform in real time. So our metrics profiler here lets me see a live feed of data coming into the platform. This is updating, you can see in real time. It shows me what metrics I'm letting into the system, how many data points per second each one is generating. You'll see it updates instantaneous what we're seeing and kind of averages it out over a window. And I can also see all the different dimensions of my data and their cardinality as well. So at a glance, you can see I've got 496 unique metrics that are being admitted into the platform right now. And we can break this down any way we want. I can add different dimensions to my view here. If I want to see broken down by environment, for example, I can filter through specific metrics or data coming from a particular application. We also have predefined filters for the different pools for our quotas. So I want to see only the data coming from the order service. That's no problem. I just go and select it from the dropdown. It's very easy in this way where if a team gets a notification, hey, you're exceeding your quota, I can come in here, filter and look at the traffic related to my quota and see exactly what is coming into the system that's accounting for that utilization. If there's a cardinality explosion, then we'll be able to see it right away. It's going to show up as a dimension here with a huge number of unique values. So kind of a bright flashing warning sign to let us know what's going on in the system. And then we can go and take action, understand what metrics it's that dimension is associated with, and either quickly block them from the platform or just go and revert whatever change, introduce that into the service if that's easier for us to do.
I think that's an important point, right? So you're able to, if you see a cardinality explosion, and let's say you had deployed something that was a security update or a fix, right? You don't want to go roll that back, right? And if it's inconvenient for a team to go fix that, you can just say here, do something, right? You see it, create a rule that doesn't allow it to come into the platform, and then it can be fixed when they get to it, right? Like the data, the metric still being emitted, but it's just not being ingested and stored.
Yeah, absolutely. The ability to do that very quickly in the platform, it's not necessarily a unique ability for Chronosphere, but it's definitely an important one in the context of being able to curb your data growth and be able to handle things like cardinality explosions. It's also very useful for a central observability team because you can start to set policies on the data that comes into the platform and gets admitted. So a very common use case that we hear from our customers is that they want to be able to do things like cost accounting. We're exploring being able to do billbacks to our constituent teams. Is that something that you can do in Chronosphere? Answer is yes, absolutely. You can guarantee quota for teams based on the different pools that we define. We can track utilization broken down by any dimension or dimensions in the system that you want, and show that back so you can see exactly how teams are performing over time. And you can also do things like set policies to say, because we're doing cost accounting based on this dimension, if that dimension is on your metrics, then you don't get to be sent into the platform and stored. So it makes it very easy for you to define these policies to let you track what's going on in the system, delegate control to service owning teams, and also take quick action when you need to, when something has been introduced in the system that is not what you expected, and we just need to kind of turn it off really quickly, but we can't turn it off the application. So we've talked about the cardinality explosion issue a good bit here, but I wanted to talk a little bit about proactive analysis too, Scott.
Yeah.
Being able to respond to an issue is one thing, but there's also that kind of general concern that we have of, am I getting the value out of my metric data that I want to be getting? Is this giving me a good ROI? Management wants to cut costs. What can I cut from the system that is not going to impact my ability to monitor my systems and ensure that we're being able to triage issues in production as quickly as we can today? That's something that we can also help with quite easily. So within our profiler, in addition to being able to let you see incoming traffic in real time, you can also see what usage looks like across all the metrics that you are sending into Chronosphere. This looks at every reference where a metric is being queried in a dashboard or an alert. It looks at direct executions, whether it's via our API or via ad hoc querying in our Explorer. And it tells you users that are accessing the data as well. All of this in relation to the cost that a metric is incurring in the system in terms of data points per second. So what I am seeing here by default are the least valuable metrics. You can see for each one, we show data points per second, as well as a utility score that tells me, where is this metric being used? How often is it being used? Score of 0, there's no references, there's no executions. This is being tracked over the last 30 days. So I can say with confidence that this metric that we're looking at here, service DB request count without instance, it's just not being used anywhere. If I want to save costs very quickly, I can drop these utility score 0 metrics and not have to pay to store them in the platform. We can also look at this from the other direction though and say, hey, what are the metrics that I really need to make sure that we retain? They're critical to the system. The team is using them all the time. And we can take a look at how they're being used too, to make sure that there isn't any inefficiency in the way that they're being stored that we can account for. So to give you an example, if we click on one of these more utilized ones, here we can see an active metric. I can see on a per dimension basis, configuration references, executions that involve that dimension. We calculate a per dimension utility score. And you can also see the cardinality of each dimension as well. So each label for your metric, its cost is being kind of considered here in relation to the value that the team is getting from it in practice. But you can see that, even in the case of highly utilized metrics, you're probably going to have some dimensions that are just not being referenced or used anywhere. So the instance label here, as an example, it's got 24 unique values, not referenced anywhere, not being queried by anyone, whether ad hoc or in dashboards or alerts. It has no utility that it's offering to us relative to the other dimensions for this metric. And that kind of makes sense. This is shopping checkout status total. It looks more like a business level kind of metric that we're tracking for our application. Completely understand where we're not looking at on a per instance basis. But what we want to do is be able to get the value that this metric is providing to us without having to pay for this additional cardinality that we're not using in practice. We're unlikely to ever use in practice. It's just kind of waste in the system from an ROI perspective. And so what Chronosphere lets you do to handle these cases is I can actually create a rule for the data that's coming in the system that will let me aggregate the data without the instance label. You're probably doing this in your dashboards already, doing some by geo region or some without instance, something like that, and just store the result within the platform. And you'll notice I clicked on the second row in my most utilized metrics. The first one is actually just that. This is the results of doing an aggregation to remove the instance label. And you can see, other dimensions are being retained. We still have high utility references, executions for them. it's easy for me to see that this metric is actually being used. And if we look at the data points per second, it's a tenth of the cost for the same, if not a little bit more utility as the original. So you can get really great improvements in your overall cost efficiency by leveraging these shaping rules within Chronosphere, as well as understanding and getting confidence around the data that the team is actually using, and being able to surface those insights to help justify the cost that you're spending on your observability platform. If the finance team asks me, why am I paying however much I'm paying, I can say, well, all the data is being used. What do you want to get rid of? It's going to impact our insights into the system. How badly do we need to curb costs? I think we are a little bit ahead of time. Is there anything that I didn't touch on, Scott, that we want to quickly show and talk about?
I think if you go, it'd be great to see the usage details area.
Yeah, absolutely.
And then
just to show you how much data is powering this behind the scenes. If I dive into the details for one of these metrics, you can see the same summarized information we had before, but it shows me all the different dashboards that my metric is being referenced from, when it was actually added to the dashboard. You can see this is being referenced multiple times in a couple of different dashboards. And I can go and click and see exactly where they're being used and exactly how, if there's any, monitors that are referencing alerts or things like recording rules, shaping rules in the system that reference the metric, that'll show up here too. And then we can also see any direct executions or what users in the system are actually executing it. So we might have situations where, a metric is being used a lot, but only one person is accessing it for some reason. Central Observability team can go and talk to that person and say like, hey, can you explain to me how you're using this? You're the only one on the team. And we can potentially find metrics that are quite valuable to give us insights that just haven't been surfaced very well. We can go and add them to key dashboards if they're missing. Or maybe the person that is the one using the metric is doing something that the other team members know not to do. And so we can kind of educate them and be able to remove that metric from the system when it's no longer being used.
One of the things I think that's important about this is that historically, developers haven't had really much insight into how much their metrics contributed to the cost or the storage. This kind of not only is this a way to identify ways to reduce costs, right, and start to make smarter decisions about what you're actually putting in the hands of the developers and the service owners. It also allows you to now have an informed conversation about when, as you said, touched on earlier, like, do we need this? Yes, here's why. Do we not need this? Yes, here's why. And maybe you need more, right? As things change over time. And I think this is important. This is like the day two. I think customers, because these systems are so complex, this solution, to be able to do this, look at this analysis is really helpful to keep that system healthy and to also make smart decisions about how you grow that observability data over time.
Right. It's about having a data-driven approach to the observability data that you're capturing. Really, it's observability into observability, if you want to get right down to it. It's the same principles for why we practice observability for monitoring our production systems actually can and should apply to the observability data that we're collecting about our production systems. And when you start applying these practices to your data, you can get fantastic improvements in efficiency. And as we talked about before, the things like performance and reliability of our platform go hand in hand with the volume of data that you're dealing with. Yeah. If I can cut the amount of data that a metric is generating into my system by 90%, then that is 1/10 the amount of data that I actually have to fetch when I go and query that metric for an alert or load that metric on a dashboard. And so you get significantly better performance without having to do anything to try and optimize the system proactively.
Great. That was awesome. Thank you. Why don't you stop sharing and I can go back and we're going to quickly recap here. Can everybody see my screen?
Yep.
All right. So quick recap here. All right. we talked about the reduction. I talked about all these benefits, open source, 100%, the reliability of the platform. And what this all adds up to is increased, the better performance in the uptime in the workflows that we've created allow engineers to basically troubleshoot a lot faster and are happier. They're not waiting for delayed dashboards or alerts or missed alerts. And so that's why a lot of the leading cloud native companies have adopted this. You can see here. And if we want to look at some of the impact that we've actually had with those organizations, for example, Zillow, 80% of the data volumes were optimized, meaning that we reduced the amount of data in their system by 80%. Abnormal, they were able to do a 98% metrics reduction via aggregation, which John talked about a little bit. And then same thing, DoorDash, a big drop. And then Robinhood, interesting here, it's basically their query latency improvement. And right, that was because they had such large data sets that they were querying across that their dashboards were taking forever. And so by being able to use the control plane, make smart decisions about doing the aggregations and things like that, it would allow them to basically improve the performance, which gave some much better visibility to the system.
Yeah, we're talking about the same end user experience, interacting with the data in the same way they did before, but you're getting much faster performance loading dashboards, enabling people to look back over longer windows of time and do historical trends that they might not have been able to do just the sheer volume of data being fetched from the system, all while delivering some pretty fantastic cost reductions to the business, which management always loves to have more efficient cost.
Exactly. And so I think you've summed it up nicely. Basically, we showed you how cloud native impacts the observability data and the impact it can have on performance. They generates a lot of data. And a lot of the systems that are out there weren't designed for this to manage this type of volume. But with Chronosphere, the control plane, as John nicely said, it lets you get faster, lets you have the same experience, the same dashboard, same alerts, but just faster at a lower cost with better performance. And with that, there's some resources here if you want to dive deeper into more about the control plane, more about some of the customer case studies, or if you'd like to schedule a conversation, let us know. And with that, we are done and we're happy to take questions.
Yeah, so great. We have some questions coming in. The first one, how do you know when you need a solution like Chronosphere?
Yeah, that's a good question. I would say like a very simple short answer would be if you're feeling the pains we've talked about in this webinar, then definitely reach out to us. Let's have a conversation. It may be that you're due to start thinking about a solution like this. In general, if you think about what we've talked about here and what we showed in the demo, hopefully it's clear that earlier is going to be better because the faster you act, the more time you have to be really thoughtful and data-driven about how you evolve your observability strategy as your business and as your application architectures grow and scale. If you are, pretty far along, you've got a large-scale application architecture that you're managing today, you have a lot of observability data, we can definitely help with those problems that you're probably feeling as a result. If you are just getting started, then you might want to wait a little while. There is a cost to using a solution like Chronosphere. There is kind of a minimum amount of data that we tend to work with, although we do have a number of customers that come to us when they are very small scale, just getting started. They know what they have in store for them, and they choose to use Chronosphere right out of the gate with the understanding that it's something that they're going to grow into a little bit. That tends to work quite well, although it is a more forward-thinking kind of approach to the situation. I don't know if there's anything you want to add to that, Scott.
Yeah, I think being proactive is better. I think we've seen a number of customers or now customers, prospects that thought they could manage it, and then something happened and they come back. And so I think being proactive is better to address that. I agree.
Right, thank you. So the next question is kind of related to your answers, actually. What's the best observability approach if we are early on with cloud native?
Yeah, good question. I'll say we might be a little biased, but I tend to think that Prometheus is a great starting point because it has great adoption and support in the open source community. It's really easy to get started with, and it is the de facto open source standard for metrics. There's open source equivalents for things like traces and logs if you're looking to kind of do a across the board approach. That'll last you pretty far. The main issue that people run into in Prometheus is scalability, and when you start getting more complex data and workloads, being able to do the types of management tasks that we showed today, there's really nothing built into the open source community or in the platform to help do that. But once you kind of start, feeling the pain of managing your Prometheus instance, it might be again time to start thinking about something like Chronosphere to help with dealing with that. And because we are compatible with open source, the conversation of how do I migrate from Prometheus to Chronosphere is actually very trivial.
Yeah, we actually did a great webinar with Julius Voles last month on 5 reasons to use Prometheus as the to start when you're starting your observability, starting cloud native, when starting on cloud native journey, basically. So yeah, it's a great webinar if you're considering that. I'd highly recommend. Julius is one of the founders and creators of Prometheus and has some great information in that webinar.
I think we still have time for one more question. So here is the question. Do most observability solutions offer aggregation capabilities? So for example, you mentioned the Prometheus has the recording rules. So what's the different about Chronosphere?
Yeah, when it comes to aggregation capabilities in Chronosphere specifically, we actually have a couple different ways that you can aggregate or generally speaking, reshape data in the platform. I'll note, first, we do support Prometheus reporting rules. A lot of our customers come from the Prometheus ecosystem, and they have quite a history of recording rules they've defined and want to be able to take with them. And that's something you can definitely do. What makes our aggregation capabilities that are built into our platform different is we have other options available. So the aggregation capabilities that I mentioned in the demo, what that does differently from recording rules in Prometheus is it's actually doing aggregation before data is being written to the system. And that gives us the ability to do things like choose not to persist the raw data. With recording rules, you are storing data in the database, you're querying it back out, generating a new metric and writing it to the platform. It's always going to be additive. With the aggregation capabilities that Chronosphere has, you can actually choose to do this in a way where we're storing less data in the database than we had to begin with. And that's how we get a lot of the cost efficiency that we talk about. It's not just dropping unused metrics, it's aggregating and reshaping incoming raw data to match the usage patterns that we see for it in practice.
Yeah, and
All
I
right.
think to add to that, what we showed you today, what John demonstrated, it's being able to understand, to do those aggregations and to make those decisions, you need to have the information about how much value each metric is delivering, how much value that data is delivering, what's the cost of it relative to its utility. And if you don't have that information and you start to do things, you can make mistakes, and you can limit the visibility of your observability solution, and that could become a problem as well. So it's important that that's part of the it's like it's a hand-in-hand thing, right? You got to know what you want to aggregate and drop, but you need to have information about that to do it in context.
Yeah, absolutely.
Okay, all right. Scott and John, thank you so much for going through everything today. So that's all the time we have for questions